Okay, so let's look at one more rational function and let's see if we can put into effect all the things we were just talking about. Okay, so you're like, that's a rational function. So what we learned new is that you can factor. And it's a 1, it's a 2, it's a 1. I can write a little easier. X plus 1 in the bottom, it's already factored. And like, I can do a reduced function. And so these reduce out, and really I can look at this almost identical function. Okay, so the first thing we want to look at, like what numbers do you want to look at? Okay, well first let's look at the ends. Okay, so we want x to approach infinity, or it could be negative infinity. Okay, what other numbers are special? Well, we want the numbers that don't work for inputs of the original functions. Okay, so my two numbers to pick would be what makes this 0, which should be 2. Now what makes this 0, which should be negative 2. Now I'm going to look at the reduced function, and the only one that shows up in the reduced function is this one. So you're like, oh, this one I don't need to check for both directions. That one I can just check for one direction. So you're like, okay, I'm going to check this one for both directions. So 2 from the plus, 2 from the left. How come? Because it makes this function, the original function, undefined and the reduced function undefined. And then this one at negative 2, I don't have that problem. So I'm just going to check the one direction. Okay, so let's see. So if we're approaching negative infinity or infinity, this function is going to behave like x cubed over x cubed, which means that the limit is 1. And since it's the end behavior, we know that y equals 1 is a horizontal asymptote. Okay, now let's do this one. Okay, so we know this is the same as the limit as x approaches 2 from the plus. We're going to use the reduced function, x plus 1 over x minus 2 squared. We're going to plug in a number a little bigger than 2. So 2 plus 1 is essentially 3. If we pick a number a little bigger than 1, so sometimes it helps to write a decimal there, you would have this number minus 2. That's a little tiny positive number. We write that as 0 plus, and we square it. So this is 3 over 0 plus. And that's one of our basic forms. It's something over 0, and that's a positive number, so we know it's going to explode up. Okay, and we do the same thing approaching 2 from the left. Okay, let's see what we get. So we would have 3 in the numerator still this time. So if we're coming from the left, it's like 1.999 something. So this would be 0 negative, but we're going to square it. So that is still 3 over a little tiny positive number. So this is still plus infinity. Okay, so at a particular value, you're exploding up or down. So that tells me we have a vertical asymptote at x equals 2. Okay, last one. Okay, so now we're going to do the same thing. We're going to check negative 2. And why don't I need to look both ways? Because when I reduce the function, I get x plus 1 over x minus 2 squared, and I can just evaluate that function. So minus 2 plus 1 over minus 2 squared, which is minus 1 over 16. And since the output doesn't exist, but the limit exists, we say we have a removable discontinuity at x equals negative 2. And that point that you would have expected to be on the curve would be at negative 2, negative 1/16, but it's not on the curve.